Hello and welcome back to Doz's Television Workshop. We are talking still about the Pi 169 chassis model 92 TV set. We think we've got a thermally intermittent VDR. Now, I did put out a request on the VRAT forum at radios-tv.co.uk, and a couple of people commented on the YouTube video, and lo and behold, a brand fire new old stock VDR has miraculously turned up in the post. Thanks a lot, Chris. Don't know what to do without you. So that's great. We think we've got, well, we know we've got the part, but whether we think we've got the fault right remains to be seen. So that's what we're going to do. Let's get into the repair. Okay, I shall be glad when this repair's off the bench. It's been taking too long, really. Right, I'm just going to take the EHT meter out of the way for a second, and the meter as well, and just move the take that off the oscilloscope probe, because that was on the end of the VDR from our measurements last time. Can I just put the chassis now up into servicing position? Yes, I can. Right. So, VDR1 is our suspect. And out it comes. I need to put that resistor back as well. R85 that we lifted up last time to prove a point. Right, that's VDR1 desoldered. And there is VDR1 removed. Probably been in there since data manufacturer sometime in 1969. And here's the brand new one. Probably been in its lovely box since 1969. Maybe Chris put it in the lovely box, don't know. Anyway, I'm just going to tuck R85 back down. Okay, that looks good. And I'm not quite sure how we get this out of it. Presumably, remove this bit of tape. Does it now open or does it slide? I think we'll remove the other bit of tape. Reminds me of those boxes that Diamond Stylish used to use back in the 70s and 80s. Ah, yes, it's sliding. Look at that. Hey, Chris, let me know if you want the posh box back, because that's rather good. Anyway, there we go. You might have a flash display rack full of those. I don't know. Right. VDR1 is there. So, let us place the new VDR in those holes. Do you know what I'm going to do? I'm actually going to leave it slightly elevated above the PCB, so it's got a bit of airflow around it anyway. If it's subject to thermal, being upset by thermal, it might do it better if it's got a bit of convection around it. Right, let's put that back in there so we can hold the chassis up out the way, get some solder. 3 points I've got to solder, don't forget, because we've got R85 back in. So that's the top end of the VDR, the earthy end. Bottom end, which is by R85. And solder up R85 itself. That's not quite taken. We really should clean some of this horrible flux off the chassis. We'll do that when it's finished. Right, that's the repair fixed. Let's hope. So we've still got our meter across the boost capacitor. We'll leave that. I should put the meter back. so you can all read that. I am going to attach the EHT meter again, which just manages to balance itself in there. Lovely. I'm going to put that VDR to one side. New VDR in place. Everything set up. Let's connect some signal. I mean, nobody mentioned the fact that I complained that I hadn't connected the signal last time. And I'm not sure it's a real necessity. But it does, of course, make sure we've got some sync. And of course, I'm missing my adapter now. Oh, that's rotten, isn't it? Where's that gone and hidden itself? I'll tell you what, we'll pause there. I'll find my adapter, connect the sync, and then we'll come back to switch on. Why not? Right, that's it. We're all sorted. Did we gain anything by scoping up the VDR or not last time? Don't think we did, so I'm just going to leave that one off. I've still got my oscilloscope connected to the grid of the PL504. I'm just going to connect that back to there to provide the earth return for that channel on the scope. We're going to need to switch the oscilloscope on. And hopefully we're ready to go. The oscilloscope takes a moment or two to boot, so we'll let that start up. Meanwhile, let's apply some power. Right. Okay. Oh, pop the meter on so we can measure the boost. Currently at minus 148 volts. And our line oscillator is running. Our boost voltage now is minus 300 and falling. It should go positive as the picture comes up. Minus 230, minus 200, 180, 160, 140. And EHT is starting to rise now. It's 5,000 volts. And we have a picture. 10,000 volts. 14. Whoa. We are up at 19,000 volts instantly. So that's too much. So what happens then? That's very interesting, because instantly that's a change. So let's switch the set back on. I've just turned the width control all the way down. We may have sort of engineered the changes we made last time. So I've got 14,000 volts with steady. Width looks excellent. That does look very good. I've got a boost voltage that's nice and steady at 618 volts. Let's just push record on the oscilloscope camera there. So you can see that's our line drive waveform at the moment. EHT is rock solid. Boost is hovering around the 620. Most excellent. That's interesting, because that's a definite change. Because with this old VDR in, you could never adjust that as much as 20,000 volts from cold. So we've had a step change. Interesting stuff. Right, I suppose now we just wait again. Right, we'll spin on. Well, welcome back. It's been so long, the meter has switched off. We have a boost voltage of 661. Moving over to the handheld shaking camera. You'll notice this is upside down, but there we are. EHT is steady out of 14, maybe 15 kilovolts there. fabulous, and it has been now for about an hour. So VDR1 is guilty. Was guilty, not that one. This one over here is guilty. This one is absolutely on the money. Now, I'm just going to try. This is why I've gone for a super shaky camera. You can see the picture is fizzing. This is in the mirror, by the way. We're looking... I'll zoom out so you can sort of see what's going on. So there's the set. The front of the screen's that way. That's we're looking in a mirror. Yeah, and you can just sort of see that fizzing around there. Now, that could be... it could be a number of things. It could be this rat's nest at the top of the line output transformer here. It could be the fact that we've got a wire strapped on the bottom here, straight to the grid of the line output valve that we're using with the scope, but that could be picking up some noise that it shouldn't be. It could be our EHT lead where we've got the extra rectifier in. It could be even the meter probes picking up on the boost capacitor where we're measuring the boost voltage. Unlikely, I'd have thought, but you can sort of see it on the scope. Let me just zoom in on there. You can see that waveform. You look at that, the cursors. Hang on, let me just try and do this. I set two cursors, one there and one there. If you look at that sort of edge there on that side, you can see that waveform moving around a little. Let me try and zoom in. You see it just moving around. That may be that noise that we're seeing. Oh, that's well illustrated there. So what I'm going to do is I'm satisfied that we've cured the fault. I'm going to take all the temporary parts off. I'm even going to remove the external EHT rectifier, join that lead back up together, insulate it very, very well indeed, and see if that removes the crinklies. If not, I suspect it's just this wiring I've disturbed around the replacement line output transformer that's giving us that grief. Right, I just thought I'd share this bit with you. I don't think that external rectifier is required anymore, so I'm just removing it. So I've removed it from the cut I made in the lead, and this is how I'm going to insulate the lead. Let me just zoom in a little. Oh, yeah. So what I've done is, obviously I'd cut the lead to insert the rectifiers in previously. So I've just joined those wires back together. The trick is to make that joint as small as possible and make it not spiky. So you want a sort of blob of solder on there. That keeps the discharge down. You don't want to make it very big, but you don't want any spiky bits. You want it to be quite smooth and round. It prevents any coronary discharge. And then I've got this syringe here, which is full of liquid rubber. And what I'm just going to do is, this is a piece of soft silicon tube that I've put over the joint, just to give it extra mechanical strength and some really good insulation properties. I'm just going to insert my syringe up in there and then inject it with silicon rubber, and you can see it working its way up the tube both ways. And then you're going to pull that out, and it's made a sticky mess. Never mind. That's sealed that beautifully. It keeps any wet out. I mean, there's not going to be any wet getting in there, but yeah, it keeps it nice and sealed. It keeps it well insulated and adds some useful mechanical strength there. Always put the tip back on your syringe. That way you don't have to throw a load of rubber away each time. So there it is. And I found this method actually works well on all sets, even up to sort of colour voltages. Although you might want to use maybe two layers of the silicon tube. I've got some thinner stuff and some thicker stuff, and one side in the other. But again, backfill it with rubber, liquid rubber, and it performs very well. So there you have it. I'm going to leave that for a few hours now to cure, and then I'm going to come back and see if we've got rid of those crinklies. I've removed all the other bits and pieces, so see if we've got removed those fizzy verticals we were seeing. Okay. Okay, the RTV rubber sealant on our EHT join there has cured overnight. I've attached the anode cap. I have redressed the wiring around the line output transformer, because I looked back in my original blog post, and there is a video of this set running, and this orange wire here tucks around the back of the valve in the original one, and these go off, and these are also looped in. So hopefully that's going to cure our crinkly verticals, and I think that's about it. So I'm going to hinge the chassis back up. I've disconnected all the other bits and pieces. Yeah, the other thing I want to do actually before I go any further is just hoover out the bottom here, underneath here. So you can see the aquadag coating on the outside of the tube. It's sort of gone a bit wrinkly. It's probably been like that since it was made, but it's flaked off in places. I don't want to disturb it too much. I have got some more sort of graphite coating. That forms the earthy side of our EHT smoothing capacitor. So I have got some more, but some of it's flaked off, and it's just in the bottom of the set here, and that's where the mains comes in. I don't want a bit sort of dropping on the mains and shorting out and going bang. So I'm just going to hoover that out, and then we'll power it up. Right, let's have a... Oh, there's a few years of detritus removed from there. Lovely. Oh, this is the bit where my daughter notices I've got a different coloured jumper on and moans about me continuity. So we'll say hello to Dr. Doz. Yes, I've got a different jumper on it. Now let's hinge the chassis back up. I'm going to spin the set round and we can watch some TV. Why not? We'll see if those crinkly verticals have gone as well. Right, let's switch on the power and hopefully watch a bit of telly. While the valves are warming, I will just confess this is the second time I've had to record this, because the first time we got copyright matched because the set was connected to a terrestrial digital box, and yeah, we were watching the Olympics and they took umbrage. So there we go. Right, so we've got a little bit of line and we've got some frame. And who's that very good looking chap? That's the only way I can think to get round the copyright, is to play something that I own. I understand from doing a bit of research this afternoon that even Test Card F and its associates are in fact copyright. There is a royalty-free test card. Belongs to a university, I understand, but they'll allow you to use that. But there we go. That's me. We seem to have lost the noisy verticals, so that's good. I think we've got a little bit more to run on our frame valve yet. Incidentally, this comes from this video footage is being converted. It's been played on the laptop, and I've got a very inexpensive HDMI to RF converter, and it's quite good actually. You can adjust a lot of settings on it. It's got a full menu, so you can adjust the horizontal. Ooh, you can even zoom in. Look, we've got a zoom function, so we can sort of scale our picture to suit our more vintage television set. Excellent little converter. Came from China, of course. There we go. The only fault I've found with it, the converter that is, not the set, is if you turn the brightness down, it starts to play with the sinks. Obviously, I think it's turning down the whole sort of gain from the on the video converter chain, and it pushes the sinks down into the noise. And there we go. Excellent little thing. It does PAL, BG, DK, I of course, and NTSCM. So it'll even, let's upset it, it'll even drive the our German sets if we have any of those in the collection. Anyway, there we go. The Pi 169 chassis, model 92, finally happy at long last. So all that remains for me to say is thanks for watching. Thanks for putting up with this long-winded story. Thanks to all the subscribers that we've gained and a couple we've lost during this series. But please like, subscribe and click that notification bell for further content, and I'll see you soon. Cheers.
Thank you.